Okay, reactions involving acyl groups. No? Okay. So, our substrate will be in this general formula. So, you have a leaving group attached to a carbonyl group. So, ibig sabihin, your L can be an OH. So, that is a carboxylic acid. OR, that will be an ester. NH2, so you have an amide. Halogen, so you have an acyl halide. And you have an OC double bond OR, so you have anhydride. So in general, we are referring to carboxylic acids and their derivatives. Okay, so yun yung ating substrate. The attacking agent, again, is a nucleophile. Either it is neutral or negatively charged. Okay. Now, in terms of mechanism, it says here it will undergo addition then elimination. But the net reaction is substitution. So in other books, they call this nucleophilic substitution at carbon sp2. Yan siya. Okay, so again, let's consider this. So the first step in our reaction is your nucleophile will react with the carbonyl. Again, so you have a nucleophile, it will look for an electrophilic group. Diba? So ang electrophilic group natin will be your carbonyl carbon. Siya ang partial positive. So the nucleophile will attack the carbonyl carbon. Kaya siya nucleophilic addition. And as you can see from sp2, what happens to your carbon? Anong nangyari sa carbon natin? What is the hybrid of the carbon? This carbon. Pakitype po sa chat box. From sp2, what happens to your carbon? Ano nang hybrid nito? Guys, what is the hybrid of this carbon? Tetrahedral siya. That's your clue. Okay, it becomes sp3. Diba? So from an sp2 na trigonal planar, it becomes a tetrahedral, so naging sp3 siya. Okay, now the next step will be elimination of your leaving group. So this lone pair will return to form a carbonyl. So magiging double bond ulit ito, magiging carbonyl, and then that will kick out your leaving group. Okay. So when it does that, you reform the carbonyl compound. Okay. Natanggal na yung leaving group, napalitan na siya. That's why it is still nucleophilic substitution. Overall, it's nucleophilic substitution. Okay? Okay. So, anong requirement natin? So, it has something to do with your leaving group. So, it must have a good leaving group or a group that can be converted into a good leaving group. Okay? So, halimbawa, ito. Pwedeng neutral naman. Yeah. Your nucleophile is neutral. It's a neutral molecule to attack your carbonyl carbon. The double bond becomes part of the lone pair of oxygen. Oxygen becomes negatively charged. Carbon becomes sp3, hybridized carbon. And then you regenerate the formation of the carbonyl group that will cleave the carbon-chlorine bond, okay? Removing the chlorine as chloride. So, since you have water as the attacking agent, oxygen becomes positively charged. Tatlo na yung bonds niya, no? So, positively charged. Of course, you need to remove a proton. Naging acidic to eh. So oxygen being more electronegative, it will abstract an electron, so cleaving the proton. So overall, at the end of that reaction, you form a carboxylic acid. So hydrolysis, siguro yun ang tandaan natin, no? Hydrolysis of an acyl halide will lead to a carboxylic acid. Okay, paki-note na lang po yun. Okay, so esters, carboxylic acids, amides generally react with loss of the leaving groups in the form of an alcohol, water, and amine. Okay, so how do you do that? Via protonation. So halimbawa, yung ester natin, okay, we cannot simply remove this. So halimbawa, nucleophilic attack. Okay, so magiging ganito siya. OR mic, OR prime. No? We cannot simply remove this OR and form carbonyl tapos nucleophile plus an OR group. This is not possible because this is a poor living group. Why is it a poor living group? Because this is a strong base. If you recall your SN1, SN2, ganun din yon, di ba? You have a poor living group, we can convert the poor living group into a good living group via protonation. So ang kailangan natin dito is to add a proton. Okay? Para ma-protonate natin ito. Okay? So, basta kapag strong base yan, it is a poor living group. We need to convert that into a good living group. Kapag protonated to, then it becomes an alcohol, which is already a good living group because it is a weak base. Yan. Kaya yung nabanggit dito guys, esters will be converted to alcohol as the living group. For carboxylic acids, OH, once protonated, it will form water. Amide, no, once protonated, will form the amine. So it becomes a good living. Now, aldehydes and ketones also do not undergo this type of mechanism. Okay? Bakit? Because, again, you have poor living groups. Okay? Kaya hindi siya dadaan dito. It will not undergo this same mechanism. Ayan. Kasi kapag aldehyde, the hydride is the leaving group. Okay? Kapag ketone, no, yung carbon ion is the leaving group. And these are strong bases. Therefore, these are poor leaving groups. Okay? Now, in terms of reactivity, so ito, we have here the most reactive will be an acyl halide. Sila ang pinaka-reactive. And then you have your anhydride. You have your carboxylic acid. You have the ester. Then finally, you have your amide. Okay, so ito na yung these are the cases, itong carboxylic acid, ester, amide. So, like I said, these are poor leaving groups, kaya they are not that reactive. For them to react, we need to add an acid catalyst. Okay, so that we can protonate the OH group, the RO group, and the NH2. Okay. Okay. And therefore, yun yung sinabi ko when it comes to relative reactivity of acyl groups. So it has something to do with basicity of the leaving group. I already mentioned. Now, let's go to specific reactions. No? Starting with, well, this is simply the conversion of a carboxylic acid to form an acyl chloride. Kasi sabi natin, di ba, acyl chlorides are very reactive compounds. How do you form that? So acid chlorides can be synthesized from carboxylic acids together with thionyl chloride. So you form your acyl chloride plus sulfur dioxide and hydrogen. Or we can react the carboxylic acid with phosphorus trichloride or with phosphorus pentachloride, okay, forming the corresponding acyl chlorides. Okay. So paano nangyayari yon? So this is your thionyl chloride, and as you can see, you just have a nucleophilic attack on this group. Okay. And then removal of, meron din tayong leaving group. No? So para siyang carbonyl, if you look at the structure, it looks like carbonyl, except that instead of carbon, you have sulfur. Tapos may leaving group ka, which is chlorine. And then after that, the chloride will now serve as the nucleophile, attacking your carbonyl carbon. So once it attacks that, again, your carbon sp2 becomes carbon sp3. The lone pair goes back to form the double bond, and this becomes a leaving group. Tanggal na siya, forming your acyl group. Now this rearranges to form hydrochloric acid plus sulfur dioxide. Okay, so pinakita lang. Okay. Now, from acyl chloride, you can react this with different types of nucleophiles, forming the corresponding products. Diba? So, yun yung kagandahan. Okay? So, if you react acyl chloride with sodium, for example, here, sodium carboxylate. Carboxylate group which acts as the nucleophile, you can form anhydride. You react this with an alcohol, you form an ester. Reacting this with an ammonia, NH3, you form the amine. Or an amine, you form the N-substituted amine. Okay, next, synthesis of carboxylic acid anhydrides. So we can react again your acyl chloride with carboxylic acid. Ayan, dito. So pwede carboxylic acid, pwede ring carboxylates, no, forming anhydrides. So here it's necessary to add a base such as pyridine. So pyridine simply acts as the base kasi we need to abstract this proton here. Okay. Why do we need to abstract this proton? So that it becomes a better nucleophile. Okay. Or we can heat a dicarboxylic acid, no? So it's a diacid. When you heat it up, you form, we remove water and you form anhydride. So from succinic acid, it becomes succinic anhydride. Okay. Or from phthalic acid, upon heating, we remove water, you form phthalic anhydride. Okay, now from anhydrides, you can react this with an alcohol, an amine, an amine to form the corresponding products. Okay. Or pwede ring water, so that will break the anhydride to form your carboxylic acids. Or if you react this with a base, aqueous solution, you form carboxylates. Okay, now, synthesis of esters. So that is known as esterification. So you have an acid-catalyzed reaction of alcohols and carboxylic acids. So that is known as esterification, or specifically Fischer esterification. And as mentioned here, it is reversible. No? So kung reversible siya, you can react carboxylic acid with alcohol together with an acid catalyst. You form the ester, or from the ester, hydrolysis, acid hydrolysis of an ester will produce the carboxylic acid and reversible. Okay? So for example, you have acetic acid and ethanol. You add an acid catalyst, you form ethyl acetate and water. Benzoic acid plus methanol in the presence of an acid catalyst will form methyl benzoate. Okay, so paano ang mechanism nito? As illustrated here, no, just like what I presented earlier, so the alcohol will act as the nucleophile, no? So this will be the one attacking your carbonyl carbon. Now, take note that this is a poor living group. And because this is a poor living group, we cannot simply have a direct nucleophilic attack on the carbonyl carbon. So that's one. So you have a poor living group. Second, you have, well, let's say this carbonyl carbon is not that reactive. Yung partial positive charge niya is quite small. Why is that? Because, remember, you can have delocalization. No? Pi electron delocalization. So you are increasing the electron density on this carbon. So yung partial positive charge niya will be very small as compared to your acyl chloride. Okay? Napakalaki ng partial positive niya because of the presence of an electron withdrawing group. No? So this is very reactive. Pagdating dito, this is less reactive dahil maliit na lang ang partial positive charge niya. Okay, so how can we increase the partial positive charge on this carbon? How can we make this more electrophilic? We introduce an acid. Okay, kaya nga dito, as you can see, the acid will help protonate this oxygen. So once protonated, so this double bond will become a lone pair. And look at what happens to this carbon. When that happens, this carbon becomes positively charged. Yan. Magiging ganito na siya. Kasi OH na yan eh. OH. So this is positively charged. So from a small partial positively charged carbon, it becomes a full positively charged carbon. Therefore, this is more electrophilic. Now, it becomes very reactive. So, it will now be attacked by your alcohol. Forming this intermediate. Okay, so once you form the intermediate, what's the next step? Again, the lone pair will go back to form the double bond. Okay, removing this group. Okay, removing water. Paano naging water to? Well, here, you have an acidic proton. Nasaan yung base? Ayun yung base. Kaya lumipat yung proton from this oxygen to that oxygen. Napunta dito. Okay, so that when it regenerates the carbonyl group, then this becomes a good living group. So naging good living group na yun. Okay, so which is water. This oxygen is still protonated, so we need to remove the proton. Hence, you reform the acid catalyst. And finally, the product, which is an ester. Okay. So if we label this oxygen with an isotopic form, no? So, di ba ang oxygen usually oxygen 16. So this is oxygen 18. So isotope ng oxygen. Lumalabas, this oxygen is the one attached to the carbonyl. So ibig sabihin, ito ang napuputol, siyang nagiging living group. At ito ang kumakabit. And OH plus H becomes water. Okay, so ganun siya. Okay. Now, so again, reversible ang reaction. So we can hydrolyze an ester in the presence of an acid forming a carboxylic acid plus alcohol. Now, esters can also be formed from acyl chlorides. So you have an acyl chloride together with an alcohol. This time you don't need to add an acid catalyst, but instead we need to add a base. Okay, so that we can remove the hydrochloric acid form. No? Kasi masyadong acidic yan. So, para matanggal yung acid, naglalagay lang. Okay? So for example, benzoyl chloride plus ethanol in the presence of pyridine, you form your ethyl benzoate. Okay. We can also react an acid anhydride with an alcohol to form the ester plus your carboxylic acid. Okay, so halimbawa, acetic anhydride with benzyl alcohol, you form your benzyl acetate plus acetic acid. Or you can have phthalic anhydride plus the alcohol, okay, you form your ester. Okay. Tapos may matitira pa kayo. Carboxylate. Okay, now base hydrolysis of esters is also known as saponification. So this is a reaction between your ester together with sodium hydroxide or potassium hydroxide. Okay, so you form your sodium carboxyl plus the alcohol. Okay. So the mechanism is reversible until the alcohol product is formed. So anong first step dito? This is simply a nucleophilic attack of the hydroxide from the base, no, sodium hydroxide or potassium hydroxide. So direct nucleophilic attack on the carbonyl carbon, the double bond becomes a lone pair, okay, forming your tetrahedral intermediate. And when you regenerate the carbonyl group, this becomes a leaving group. Okay. Now, the leaving group, like I said, is a strong base, so it will react with the acid. Ang acid natin ay carboxylic acid. So these two will react, forming your carboxylate plus you have your alcohol. Okay, and this is the basis, guys, for making your soap. So saponification is part, as an example of saponification, you have soap making. Paggawa ng soap. So yung ester that you use will be oil or fat. You react this with sodium hydroxide or potassium hydroxide. Around 10% maybe or 20%, pwedeng higher. Then you simply boil that. And then the product will be a sodium salt, which is now your soap. And the alcohol will be glycerol. No? So yun yung paggawa natin. So that's saponification. Okay, you can also form lactones. No? So paano yon? So this is acid catalyzed reaction forming cyclic esters. Okay? So you start off with a gamma, delta or gamma hydroxy acid. Okay, so alpha, beta, gamma. So may delta tayo na OH group. So this will act as your nucleophile. And you have here the carboxylic group. No? And this is acid catalyzed. So again, the first step will be protonation of this oxygen, making this carbon more electrophilic. Then you have your nucleophilic attack, forming your six-membered cyclic structure. And then this proton will be transferred to this oxygen because this is a base, you have an acid. And then finally, next, you reform the carboxylic group plus removal of the leaving group. Okay? And then finally, deprotonation of the oxygen, forming your lactose. So parang cyclic esterification siya. Diba? So, diba, esterification is a reaction between a carboxylic acid and an alcohol. So this is a intramolecular esterification. Okay. Lactones can be hydrolyzed with aqueous base. Okay, so for example, your lactone, you react this with a base, and you form your, you break the cyclic structure, you have your alcohol group and carboxylic. Now, when we react this with the acid, just simply to protonate this carboxylate, then you have your hydroxy acid. Next, amides. Synthesis of amides can be done by reacting amine with acyl chloride or acyl halide. Okay, so this is again a simple nucleophilic attack on the carbonyl carbon. The double bond becomes a lone pair of oxygen. And then when you regenerate the carbonyl group, we kick out the leaving group. Okay. Next, this nitrogen becomes positively charged in the process. Therefore, it is acidic. So we remove this proton. It will react with, well, another molecule of the amine. No? Kasi ito ay base, and then you have base, forming your amide. Okay, so anhydrides can also react with amines to form your amide. Then reaction of cyclic anhydride with amine followed by acidification can yield to both the amide and carboxylic functional groups. So this is quite unique. So you have your phthalic anhydride reacting with ammonia as the nucleophile. No? So initially you form your amide, and then you have your ammonium carboxylate salt. No? Then finally, simply protonation of this carboxylate group will produce thalamic acid. Okay. From thalamic acid, we can dehydrate, meaning remove water. Under high temperature, you form thalliumide. Okay, So we have here amides from carboxylic acids and ammonium carboxylates. So we can have a direct acid-base reaction between ammonia and carboxylic acid. Acid-base lang yan, forming an ammonium carboxylate. Now, some of these ammonium carboxylate salts can be dehydrated, meaning by applying heat. Then it rearranges to form your amide compound. Okay. This reaction can be used to form amides from carboxylic acids and amines. So meron tayong tinatawag na DCC, dicyclohexyl carbodiimide, which activates the carbonyl group of your carboxylic acid. Okay. Again, di ba sabi, just like for esterification, diba? Your carboxylic acid is not really that reactive. So we need something to increase the electrophilicity of the carbonyl carbon. So one way to do that is by reacting your carboxylic acid with DCC. Okay. So in a way, instead of protonation, nag-react siya doon. And as you can see, the oxygen becomes positively charged. Then via pi electron delocalization, dito naging positively charged yung OH group mo. And then there will be proton transfer. Saan yung proton transfer between this nitrogen, which is negatively charged, and this proton. So lilipat si proton, acid-base reaction siya. This proton moves to that nitrogen, forming this intermediate, followed by reaction, nucleophilic attack of the amine. So nucleophilic attack on this carbon, yan, maganon. Tapos, balik na to form the double bond, removal of the leaving group, okay, forming this. Okay. Of course, this proton will have to be removed kasi ito ay magiging negatively charged. So this becomes the base, you have an acid. Kaya napunta siya. And then finally forming the amine. Okay. This is very useful, guys, in the synthesis of peptide bonds. So this is useful in synthesis, in peptide synthesis. Okay. So, kasi kailangan mo ng carboxylate group, di ba? And an amino group. Okay. So, doon ka nakakabuo ng peptide bond. Actually, the peptide bond is simply an amide bond. Ito, amide bond. Okay. So, ito yung ginagamit na parang catalyst. You add DCC. So, very useful yan sa inyo. Okay, next, hydrolysis of amides. So, acid hydrolysis of amide will yield your carboxylic acid. base hydrolysis of an amide will yield a sodium carboxylate salt. Okay, so again, what happens here? Amides, remember, are weakly reactive towards nucleophilic attack. So again, we typically need to use an acid catalyst to make this carbonyl carbon more electrophilic. Diba? Then it will be attacked by a nucleophile such as water. No? Then again, you have your acid, tapos may base ka. So, proton transfer from oxygen to nitrogen. Giging ganito. And then, regeneration of the carbonyl compound, removal of the leaving group. Then finally, removal of the proton from the carbonyl oxygen, forming your carboxylic acid and ammonium. Kapag base naman, well, direct attack naman siya. Okay, why? Because this is a strong nucleophile anyway versus water. Water, di ba, is a weak nucleophile. So, ang hydroxide is a strong nucleophile. Pwede na niyang direct attack on your carbonyl carbon. Okay? Forming this intermediate, and when this is, meron tayong acid. Diba? So, when we remove this proton, oxygen becomes negatively charged, regeneration of the carbonyl, removal of your amino group, which becomes a base, and then you have your acid, then you form this. So you have your carboxylate plus ammonia plus the base. Okay, nitriles. Okay, nitriles from dehydration of amides. So you have an amide, you can react this with phosphorus pentoxide or boiling acetic anhydride. So you form your nitride. And then, kapag hydrolysis of nitriles, okay, acid hydrolysis of nitrile will form carboxylic acid. Base hydrolysis of nitriles will form the carboxylate. Okay, and this simply shows the mechanism for that. First is protonation of the nitrogen, and then the pi bond becomes a lone pair for nitrogen. So that activates this carbon. So from a small partial positive charge, again, that is done to increase the electrophilicity of the carbon. No, naging full positive na siya. So it can now be attacked by water as the nucleophile. Okay. Next, removal of the proton. Okay, to form an alcohol group. And then what happens is you have an acid base. Ito yung acid. May base tayo. This is simply to protonate this. You have your resonance structure, pwedeng ganito, which then we can remove, well, several steps pa for amide hydrolysis. Pero ito na yun eh, amide hydrolysis na siya. Diba? Nasaan yung kaninang amide hydrolysis na? Ayan. Correct? So you have your amide hydrolysis forming your carboxylic acid. So dun na papasok. From here, amide hydrolysis to form carboxylic acid. Oops. Okay. Siguro last na to. Let me just show you synthesis of salicylic acid. No? So the salicylic acid is synthesized from phenol with carbon dioxide in the presence of sodium hydroxide under high pressure and temperature. So first reaction will be reaction of the base with the phenolic proton. Magiging negatively charged to. When this load pair delocalizes towards the ring, this bond will now, this carbon becomes nucleophilic and it will attack this carbon. As you can see, para siyang carbonyl group, di ba? This part. Okay. Kaya kakabit na siya doon. Okay. And then protonation, you form your salicylic acid. From salicylic acid, we can synthesize aspirin, which is acetyl salicylic acid. So from salicylic acid, we can react this with acetic anhydride in the presence of an acid. So magiging salicylic acid na siya. Plus your acetic acid. Or something similar, you can have synthesis of oil of wintergreen. So again, using salicylic acid with an alcohol, you have an acid forming an ester. So pareho silang ester. Diba? This is your ester group. Here, you have an ester group. So esterification reactions lang sila. Okay? So now let's look at Claisen condensation. So for Claisen condensation, this is a reaction involving esters with alpha hydrogens. Okay? So ano yung mga esters with alpha hydrogens? Such as this. So remember, this is your alpha carbon. Let me just indicate that. This is your alpha carbon, and therefore you have an alpha hydrogen. Okay. So here you have an ester. Well, you have two different esters. The reactant requires the use of a strong base, such as sodium ethoxide. So what it does, you have here a strong base, and your alpha hydrogen is the acid. So you have an acidic proton. So the base will abstract the proton, negative charge. It will abstract the proton. This will form a sort of enolate. Okay. So yung isang product natin will be, of course, ethanol. This will become ethanol. And then what remains here will be something like this. Nakabaligtad lang. So you have here CH2 that is negatively charged. So this carbon ion now will act as your nucleophile. Okay, so siya na yung nucleophile. So this nucleophile can now attack this carbonyl carbon in the usual manner. Diba? So when it does that, so what will happen? You have your benzene ring. Tapos oxygen, negative. Tapos O, ethoxy group. Tapos nakakabit dito yung CH2. And then you have your carbonyl O ethyl group. Ito na siya. So ito kumabit siya doon, forming this. And then when this goes back, to reform the carbonyl group, we kick out this leaving group. So kapag umalis na yan, you form this. Plus, again, your ethoxide. And then, of course, this base, we have a base, we can stop the reaction by reacting this with an acid. Okay, kaya nga meron on the second part, you have your acid workup. So just to finish up and form your ethanol, yun lang. Yun lang ang gamit nitong acid natin. Okay? But this is the final product of the reaction. So that is Claisen condensation. Now, of course, you can use other bases for as long as you have a strong base. So such as sodium ethoxide, you can have sodium amide, sodium hydride. And these are strong bases. So this is useful when you want to synthesize keto esters. So you have a keto group here, and then you have an ester group. So this is done using mixed esters. Okay? So that is Claisen condensation. Okay. Next, you have the Hell-Bolhart-Zelensky reaction. And this is similar to haloform reaction. We'll discuss haloform in a little while. But basically, you have an acid-catalyzed alpha chlorination or bromination. So again, the target here is this alpha carbon. We are replacing, we are going to replace the alpha hydrogen with a chlorine or bromine. So kung chlorination, then this will be Cl2. So for bromination, in the presence of phosphorus as a catalyst, and you form this alpha chlorinated or alpha brominated carboxylic acid. Okay. Now, why is it important to have an alpha bromo carboxylic acid? Because you can convert this later on to an amino acid by simply reacting it with ammonia. So, paano na to? So, gamit natin dito will be SN2 type of reaction. Diba? Replacing bromine with an amino group. And now you form your amino acid. So, it's a precursor to amino acids. Kaya mahalaga to. Itong reaction na to from carboxylic acids. Okay? Then finally, you have reduction of acyl compounds with lithium aluminum hydride. So the hydride from lithium aluminum hydride will serve as the nucleophile in the reaction. So dahil nucleophilic attack, same thing, no? It will attack the carbonyl carbon, which then results to, you have CH3, CO minus, okay, tapos OCH3, and then you have your H. Tapos you regenerate the carbonyl group, you cleave the carbon-oxygen bond, okay. So you form, eto na. Okay, one part is it will form an aldehyde, no? And then what happens to the OCH3? It will attach itself to your lithium. So magiging, itong part na to will become, so lithium, aluminum, H3, OCH3. Kakabit siya doon. Okay? Now, further reduction of the aldehyde will produce an alcohol. Okay? So, ganun din naman ang reaction. Hydride will still serve as your nucleophile. It will again attack the carbonyl carbon. Okay. Okay. And then, acid workup, meaning magdadagdag lang tayo ng acid dito. So, acid workup to form your alcohol. So, CH3, CH2, OH na yun. Yun. So, alcohol. Okay? So, the nice thing about this reduction reaction, so lithium aluminum hydride will act as the reducing agent. So, carboxylic acids and their derivatives, no, such as acyl halides, no, esters, anhydrides can be reduced by lithium aluminum hydride to form. Initially, it will form your aldehyde, and then the reduction of the aldehyde will form your alcohol.